So, anybody else wants to talk to me about their assignments, difficulties, about this course in general, your experiences so far? How can we improve it? We have about 2 more minutes. We can just take one discussion. Hello, Shweta. I'm loving all the assignments, yeah. I'm reading every assignment personally, and some of them are like
Hello,
really good.
ma'am. Ma'am, can I talk,
Yes, Shweta.
please?
Yes, please.
Ma'am, I was absent, not absent, like first assignment, in first class, I was absent. So I am really confused about my submission date, like when I
It's
have
okay.
to submit my assignment,
It's okay.
like,
It's okay. Shweta, this is not a school.
sorry, ma'am, and I was so
It's okay.
conscious
It's okay if
about
you
this.
be late. It's okay if you be busy. Everything is
No,
okay.
ma'am, no busy. Actually, I got the mail only yesterday. So,
It's okay.
study
Calm down.
my first
Nobody's cutting your marks. Nobody's cutting your
class,
marks. It's okay.
and I really didn't know about this feedback and all. And today
No
I watched
problem. No
all the
problem.
videos
No
and I
problem.
got all the information, and I really loved that, and it was very helpful for me
Good.
after I watched that videos in Facebook, and now it is easy for me to got you.
Nice. Good to know, Shweta. But don't worry, everybody. We are keeping the deadline so that everybody is able to complete the course in time. Otherwise, procrastination is the best friend of humans. More we procrastinate, more we pile up, and then it becomes difficult to do something. And we have interesting things lined up. You must have seen today that we launched a challenge, and we will be launching similar challenges which will bring out your creativity. And if you must have also noticed that most of the assignments that we are giving you are to induce your creative thinking and problem solving skills. It's not just about drones, the technical part of it. I know most of you are engineers out here, and you will get it. You know how to learn online. You how to you have that in our knowledge available. But what I want you to do is bring out the leader in you. So I remember today one of the projects, Ashish project, and he said that I'm just an undergraduate student, but you made me imagine that I'm a leader. So which was a compliment for me, and that's what I wanted to do. Start thinking like leaders. All right, so I think it's time to start our session. Allow me to share my screen, please. And also, as a feedback which I got yesterday, no, I will not repeat the rules again. Okay. So I just realized that I didn't change the cover image. Apologize for that. Anyway, welcome to the class 3 of advanced course in drones for development. And today we are especially thankful for two of our partners, MapHub and DroNepal. We have Achyut Krishna Pandey, who is the founder of MapHub, and we have Darpan Pudasaini, who is the CEO of DroNepal, who will be telling us about their work post disasters in Nepal. As we know, Nepal is extremely disaster prone, not just for earthquake, but even regular landslides, flooding, everything. These two gentlemen who have done amazing work in Nepal would be talking to us about that. The first speaker for the day is Achyut Krishna Pandey, and I request Achyut to please take over.
Thank you, Ruchi ma'am, for the introduction.
Can you
Welcome
put on your
everyone
video,
for.
Achyut? Achyut, can you put on your video?
Sorry.
Can you put on your
Uh,
video?
can everyone see me?
Yes. Great.
Okay. Um, so I will just put on my presentation.
Sure.
Uh, Just give me 1 minute.
So we have 2 or 3 more sessions in the disaster series. After today, tomorrow we'll be discussing about preparedness and vulnerability. Again, 2 extremely great speakers from my friends will be there tomorrow. And after that, we'll be moving on to healthcare topics. Over to you, Achyut.
Thank you, Ruchi ma'am. Already, my name is Achyut Krishna Pandey, and I'm the founder of MapHub. I also work as an individual consultant for different NGOs and NGOs. Currently, I'm working as a JS and RS consultant for ISHIMOD, International Center for Integrated Mountain Development. There, I lead the program for taking the disaster and preparation for disaster in the Hawaii region for flood disaster. Let me start to the topic. Let me just give a brief introduction to the typical disaster cycles, what disaster cycle is. So this disaster cycle mainly consists of prevention, preparedness, response, and recovery. So there is first one is the prevention. It's a cycle, so let's start with the prevention. So prevention, that means reconciliation and mapping. So where you do certain kind of activities to help you prevent from disaster. You analyze the structural integrity analysis, and many more. Preparedness, that is the temporary preparedness, that is the construction of the temporary infrastructures, management of the supply and delivery channels, detections and early warning, establishment of early warning systems. And then there comes the response, that is the emergency support, where when the disaster strikes, then you provide emergency supports, search and rescue operations, relief distributions, and impact assessment. So, and then the fourth one is the recovery, that is the insurance claim, risk assessment, logistic supports, and reconstruction. So the post-disaster damage assessment, today I'm going to present on the post-disaster damage assessment and how UAS or UAV or drone can support in these kind of activities. So drone can support in all 3 different aspects of disaster management. The first one is the pre-disaster preparedness phase, where drone data can be utilized for risk assessment, for emergency preparedness, and for mitigation strategies. I will come to the example later, but let's just talk with the topic only. Then second phase is during the emergency phase. When the disaster strikes, then the drone can be used in ways to respond, to provide rescue and support during the emergency phase. And third is the post-disaster assessment, where drone can be utilized for survey and damage assessment, identification, prioritizations, and implementation of emergency intervention activities and stabilizations, assessment of recovery and rehabilitation needs. So with drones, you can first identify people who needs rescue. Second, you can identify at large scale, you can identify the impacted areas, vulnerability assessment, that can be done. So one of the major key aspects of post-disaster assessment is the assessment, comprehensive analysis of impact created by the disaster and the associated cost. Cost doesn't mean only the cost of the money. Cost also includes the human cost, the agricultural cost, economic cost, different kind of costs are there. So assessment of all of the cost that has been destroyed by that has been impacted by the disaster can be analyzed using a drone data. So in the recent condition, how we are for the post-disaster damage assessment or any kind of other assessment, we are using satellite data. Satellite data, we have different kind of satellites data. Satellites working at around 800 kilometer, normally 800 kilometer away above Earth's surface. Then what is the major problem with the satellite data is the resolution is really low. There are few paid satellites companies that can provide good data, but we have to purchase that data. So freely available data, we have Landsat that gives resolution at 30 meter. We have Sentinel-3 that has a resolution of 15 meter. And another one is SAR data, but SAR data is quite difficult to interpret since it's a radar data, that's synthetic aperture radar. So it will be quite difficult to interpret that data since it's a backscatter data. It's not optical data, it's a backscatter data. It will be much difficult to interpret. It has the satellite data has very low accuracy. Cloud cover during a flooding season, most of the cases that I work on is a flood situation, and during a flood scenario, most of the data that I receive from satellites are all cloud covered data. So removing the cloud is a very difficult task, and I lose a lot of data. So using optical satellite is not an option for me. Secondly, the revisit interval. Revisit interval is at how many days the satellite scans the same area again. Landsat has a revisit interval of 16 days. So same piece of land is scanned at 16 days interval. So if you have if it's captured at January 1, then another image will be captured for the same area will be captured at the January 16. So if there is any kind of disaster that happens between that time, from January 1 to January 16, between that time, then I cannot get that data. I cannot get that information. Same cases for the Sentinel data, Sentinel SAR data, and Sentinel-3 data also. Both has a revisit interval of 12 days. It has a two constellations. It has a two constellation, which gives us a revisit interval of 6 days. But this one is another SAR data. So using SAR data is quite difficult. We have planes, but using planes is quite costly. We can use deployed planes, airplanes, helicopters during a disaster, during a post-disaster assessment, but using such heavy equipments, it's time-consuming, it's labor-intensive, cost-intensive. And the resolution, we can get quite decent resolution, but there is always a trade-off between the resolution and the cost. The best option, what we have right now, is the use of UAV. UAV, we can fly it from a height at an elevation of 50 meter to 100 meter. There are different kind of UAVs, different kind of platforms that you can use during a disaster for different purposes. You can use different kind of equipment. So why use UAV then? During a post-disaster assessment, UAV can facilitate the faster and timely data capture. UAV is equipped with camera sensors which can produce frequent imagery photos of the area of interest. What is the advantage of using drone during a post-disaster assessment? That is, we get timely data. I already talked about the drawbacks of satellite data. We cannot get data at a timely interval, but using drone, you can get timely data. Low cost of operation. The cost of operation is really low compared to the purchasing of high-resolution satellite image, or for purchasing for using a helicopter or a plane. No.
I think Achyut has left the meeting. Maybe he lost his internet. There are a lot of internet issues these days. Let's just wait for 5 minutes. Meanwhile, anybody wants to ask? There are some questions out here. Some comments. Can you hear me, everyone? You can't hear me either.
Yes, ma'am, we can hear you.
All right, thank you. So I think Achyut's internet went down. Then I think he'll call back again. Meanwhile, let me address this question. Okay, Dilip sir is saying that regarding the challenge one that we have given you for Map My Town, would you consider requesting a GIS expert to speak for 10 minutes on how to go about using the base map and the mapping tool? Yes, we can do that, sir. So what we can do is we can organize a complimentary webinar for you. Would that be okay? Maybe we can take a poll from you all that how many of you need this kind of learning or training, or how many you can do. But what I wanted you to do is use whatever map is available to you. It could be a paper map, it could be just Google map, or you can just create your own map. For example, if I live in this town, then I would create a rough map according to my understanding. We want to be like really basic. It's not necessary that you want to use earth images right now, so we are not reached that level of our assignments yet. We have a lot of assignments lined up, and so we're going like gradually, step by step. Right now I also want to access your own knowledge. So how many of you are like real GIS experts in this group who can use sentinel images? Maybe some of us are comfortable with Google map. So this will also tell us that what is your current level of knowledge and how do we want to build up, because we are a diverse group. In this group you have super experts as well as super beginners. So let's try to see and evolve gradually, give each other the time. And Mariam was asking how expensive is satellite data? Is it affordable for small NGO? So Mariam, I do know of certain not-profits who have received funding to do these, to give away these images for free. Some of them are available, but otherwise, yes, it becomes expensive. So having a funding for a project is extremely important if you're an NGO or a partnership.
Dr. Jia, Dilip here.
Yes, Dilip, sir.
Actually, what I was trying to say is that since many of us are, I have some knowledge about GIS and things like that, but many of the participants may not be actually having any knowledge. So I was not, actually asking you to conduct a training session for this, but maybe we can possibly give a small briefing from an expert of, which would be probably an easier base map to be used and easier mapping tool. That's it. Nothing serious, like maybe an introductory session.
Yeah,
Thank you.
yeah, right. I can give you what I understand from whatever I have spent time in understanding GIS, just for the beginners, because here we have beginners as well who have no experience in GIS, no prior experience. So GIS basically means geographical information system, and this is a location data. As we know that location is extremely important for all of us. Now in COVID-19 you've been seeing maps. I think all of you must have seen maps everywhere, wherein you see the entire world map and you see the number of cases in every country. These maps have been going around. This is also GIS. Okay, so this is understanding that any data that you have can be converted into a location data, and this data is extremely important for decision making, for planning, for development, for anything. We want to go back to our school days wherein, remember, we used to have that mapping exercise. We were given a blank map and we used to plot our places there, capitals of states and countries. So this was the exercise which was given to us in school, but we never really took it seriously. I at least did not take it very seriously. I used to hate it. But then now when we see so many things happening around us and we realize that geographical information is extremely important. So I think till Achyut comes, maybe we can start with Darpan. Darpan, would you want to give a short session on how to save a map from Google Earth right now?
Yes, Ruchi, why not?
Yeah, please do
Always
that.
ready.
We have Darpan. Darpan has been using a lot of GIS in his project, and he has also been one of my trainers in Nagaland. So yes, Darpan, please take over from me. I'll be very happy. You can extend your session. I don't know what happened to Achyut's internet, so let's not waste time.
I think we're having some electricity problems in these areas. Maybe he's also nearby.
Maybe. So you can start your video, or you can show your screen to everyone.
I'm just quickly opening Google Earth, so just give me a moment.
Sure. So everybody, Google Earth is the most comfortable tool which I have seen to using maps. So we have Google Map, which is a simplified version. Google Earth is way more advanced. So I would recommend everybody to download Google Earth on your computers and mobile phones, but computers are better because you get way more tools on a desktop or a laptop to work with. And that's really interesting. I can spend hours looking at Google Earth, just going to places where I've never been before. I do that as well. So just play around with Google Earth. You would start loving it, start using the tools on the top, and you would know what GIS is all about from there. That's like the basic of GIS. You can start plotting stuff and making lines, making circles, do whatever. So Darpan will show you now.
Hi everyone. So Ruchi, can you see my screen?
Not yet, just hold on.
Okay.
Yes, we can.
Okay. So I hope it's understandable because on my side it's just flashing randomly. Is it clear?
Yes, it's clear.
Okay. So hi everyone. I'm Darpan. Maybe we'll go into introduction in the next session where I have my presentation. For now, I just wanted to quickly share about how you could maybe download a satellite image from the Google Earth itself. So Google Earth, it's a very easy to use tool, but millions of engineers use it, and even though we own, or even though a company owns lots of expensive GIS softwares, Google Earth is the first go-to solution for everyone because you can work on it really fast. And for preliminary mission planning and doing all those things before going to the field, we use Google Earth a lot. So, and like Ruchi said, um, it's really good knowledge to have. So I'll just don't want to waste your time. So let's just quickly jump into it. So if you have the Google Earth installed, and then you open, this is the first screen that you are going to be shown. And what you can do is, if you can see a search box right here, I hope you can see it. So you can just type the name of your city. So for instance, let me just type Kathmandu because that's where I am right now. And if I just click and hit enter, it will show me all the list possible places that are relating to Kathmandu. Right now, we only have one Kathmandu. That's why it's showing one Kathmandu. But for instance, if you type Delhi, then you might get lots of results. So please be careful which location you are choosing. And then if you double click this, whatever shows on this list here, then it will just automatically zoom into that place. Now you can see the satellite image of Kathmandu here. Let me just turn off these layers. Okay, so this is the aerial map of Kathmandu. Depending on my purpose, what kind of data I use might be different, right? So I might need a satellite map so that I can present something that the whole Kathmandu Valley is going to be designed upon. So for that purpose, I'll just have to adjust my zoom accordingly. So right now, we're like several hundred meters, like 700 feet up in the air. But if I just zoom in, so it's really easy. You can use your mouse to scroll in and scroll out for zoom in and zoom out. So for instance, let's say that I need a satellite image of this particular football field that we can see. Even I don't exactly know. Oh, okay, so this is called Dasrat Rangasala of Kathmandu, I think. So the trick is like, for instance, suppose that I need the map of this area. So what I do is I just zoom it to the level up to which I require the map to be zoomed down to later. And then what I can do is like, I hope you can see these really small icons as toolbars. So we don't have much time to go through all this, but if you can see here, the third last option there says save image. So it's really simple. You just, adjust your display for the location and for appropriate zoom levels that you want to save the image. And then you just hit this third last icon that says save image. So when you hit it, then you'll be given few options like this untitled map here. This is the place where you can enter a map. So when I just click there, I can write map of KTM. And then you can see legend over here. So if you have like lots of places or landmarks here, you can just show them all in legend. But for now, we don't want that. So what you can do is, you can just change the resolution of the image that you want. For instance, I want a full SD image. And then I just hit save image, just give it a name, map of Kathmandu. So it will take some time to save the image. So I'm not sure that if you can see the window here, because Google is sharing just the Google Earth image, but the image is already saved on my desktop. Let me just show it to you. Okay, so this is the photo of the Kathmandu that I just saved from Google Earth. Now I can use this photo for my projects or whatever I want. So it's as simple as that. But there's one thing that we need to consider. There's the fact that, you know, the image that I just saved from Google Earth, it's just an image. So we don't have the information of GPS coordinates. So we call it geolocated image per se. Like if we click photos from our smartphones nowadays, the smartphones are able to geotag our photos. So what that means is if I click the photo at some random location, the phone will also save the GPS coordinates of the location along with the image so that I can retrieve it later. The image that we just saved using Google Earth, it's not geolocated. So you can use it as a base layer images as long as you are okay with adjusting it. So there are far more, few other complicated tools that we can use to get geolocated images. But I think for our purpose, for the question that was raised earlier, I think this much is enough for now. That's pretty much it. Thank you, guys. So I hope you understood me.
Thank you, Darpan. We have Achyut who has joined back. I think, Achyut, are you back?
Yes, Ruchi ma'am, I'm back. Sorry, my connection was lost. So
Okay.
I was presenting, but my connection was lost, and I just realized after I finished my presentation.
Oh, all right. So please start presenting again.
Okay, I'm sharing my entire screen, so that's much easier for me. Share. So let me again start. My presentation was on the post-disaster damage assessment using UAS. So I'm going to again represent it.
You were on slide number 6 when we lost you.
Slide number 6. Okay.
Yes.
So the motivation for drones, why we need to use drone for surveying. So I already discussed that we are not getting timely data from satellite. So we can get timely data, but we have to pay a lot of money for that. The paid like commercial satellites, we can get high resolution data up to 50 centimeter data, but still you cannot get timely data from those satellites. So next one is the cost of operation is really low. And you can consider the cost of operation with other techniques for disaster risks, like post-disaster assessment, using helicopters, using planes, or using satellite image, satellite data. So drone will be the very low cost for operation. So since you are using drone, there is no flight crews are not at any risk. You get very high resolution images using drone. You fly below the cloud, so the cloud cover, not a problem. If there is a rain, then there will be a problem with like specific kind of drones. But if there is IP67 rating or IP68 rating drones, then you can still fly it in the rain as well. And the operational flexibility is really high using a drone. So let me discuss on the process of how drone data is captured in field. This is just a normal introduction, how drone data is captured, like how drone works. So first one is data collection. So data collection includes the field planning. You have to identify which area you are going to fly. You can see in this one is an example of Pix4D capture. You can use Pix4D capture. You can use the base map already inbuilt in Pix4D. You can use H3 image as well. You can use satellite image as well here. You can see there is an icon that you can select between, you can select the base layers. So you can make the flight plan for your specific area where you want to fly. If there's you cannot capture the entire area in one flight plan, then you have to relocate and make another flight plans and then continue your survey. After that, you process the data. During the processing phase, you can use different applications to process the data, and you can get desired outputs. What kind of output you want, you can use the similar the related kind of processing softwares, and finally you will get the output. So there are multiple platforms and sensors for like drone. Few platforms I'm going to discuss. The first one is a fixed wing. Second one is a multi-rotor, and we have a VTOL. VTOL means vertical takeoff and landing, but once it's takeoff vertically, lands vertically, but once it's in the air, it works as a fixed wing drone. So you have the flexibility of vertical takeoff and landing, and the capacity, like time duration, the capacity of a fixed wing drone. So examples for use of virtual drones is if you are doing a corridor mapping, you are mapping in a small corridor or in a ridge or in a valley, small valley, then you can use fixed multi-rotor drone, or you can use a visual drone. So it will give you operational flexibility. So if you are mapping the large scale area, flat area, then you can use fixed wing drone. Then you have the sensors. You have multiple sensors that like many different kind of drones support different kind of sensors. Fixed wing drones can support different kind of sensors, and multi-rotor also can support different kind of sensors. So few example of few sensors are, you have RGB sensors, the normal camera sensors. You can use that sensor in the drone to capture RGB composite, RGB image. RGB image you can use it for like inundation mapping. In case of flood, you can use it for inundation mapping. You need to know the extent of flood. Inundation means you need to know the extent of flood, how much area has been impacted by flood. You can identify that using RGB. If you want to use for a rescue mission, you want to know where people are located for rescue. You want to rescue people and you want to know where people are at the particular time. But then you can use a thermal camera. But it also depends on the condition. If you are working in the day, if the people are in the top of their building, then you can directly use a RGB camera. But if you are working during the night, then you can use a thermal camera. Thermal camera will give you the thermal image of the people, so you can identify where people are. So here is the basic outputs of a drone. The first one is a 3D model. 3D model, you can see there in the top, the big one. That's a 3D model. These data are generated from the RGB image. Second one is the digital surface model. You can generate digital surface model from there. You can generate digital elevation model as well, and you can generate contours as well. That's the elevation map. So all of these three down below here, this shows the elevation of your ground. So digital terrain model or digital surface model, we have two different kind of digital elevation model. So digital elevation model, DEM, it's a raster image, it's a raster surface, it's an image that gives the information of the height of the surface. So that's a digital elevation model. So we have two different kinds of digital elevation model. One is the digital surface model that gives the height of the surface. If you are flat, if there is a tree, so this one is a digital surface model. It gives the height of the surface. There is the tree, so it gives the height of the tree canopy. Another one is the digital terrain model. This gives the height of this represents the height of the terrain. So all of the trees are removed from the data, and it gives the height of the below ground surface. So there are few limitations when you are using an RGB image. And these are if there's a large canopy cover, if you cannot see ground from anywhere, the accuracy of your digital surface model, digital terrain model is really low in those areas where there is a large amount of tree cover, like canopy cover. For that, you can use different other sensors that can penetrate the vegetations. You have LiDAR sensors, or you can use other sensors as well. You can use radio waves. So another one is during a disaster phase, how drone you can use the drone. You can use drones to send the medical supply or the relief materials to people at need. You can identify where people are located. You can send rice rafts. You can use thermal image during the night to identify people. You can see you can send the life rafts as well during a disaster, like during a flood disaster. This is mainly during a flood disaster. So why use a UAS or unmanned aerial system, unmanned aerial vehicle or drone? Why use the drone during a flood emergency response? So I'm working with three different phases of like flood disaster. Flood disaster risk assessment. You can use drone. The digital elevation that is generated from the drone can be used to assess how much area will be flooded at a given discharge level, given water discharge level. For a river, at what discharge level you will have a flood and how much area will be flooded, inundated. So that you can assess that using the data like digital elevation model generated from UAS, from drone. Here is another determining digital terrain, like terrain elevation. You can generate terrain elevation. Same data you can use to model the flooding extent. You can identify the evacuation route and flood warnings. You can provide flood warnings as well. Based on the flood risk assessment and flood extent map modeling, you provide like flood early warning. If you see a certain amount of like water above the warning threshold or above the danger threshold in the upstream, you provide early warning. So the other one, the identification of people during a flood, identification of people that needs to be rescued, and for supplying of emergency relief supply, emergency relief materials. Here's an example of inundation map made. This one is the inundation map from September 1st. So Nepal-India border, the border, Nepal-India border boundary, like embankment was breached, and we can see the huge flood in the BR side. This one is the BR side, is the Nepal. Less amount of flood in Nepal part, but lots of flood in the BR side. So we can create this kind of inundation mapping. So these maps supports in like relief operations as well for response. For disaster response, this support disaster, and this kind of maps also supports in post-disaster assessment. Like for post-disaster assessment, you need to know how much area has been impacted to identify how much loss has occurred. Another one is, this one is an example of building damage situation during an earthquake, like number of buildings damaged during an earthquake. So here it's these are the buildings that has been damaged. This is generated using the digital elevation model. If you see a digital elevation model that has the shape of the house, the proper shape of the house, then you say this one is not the damaged house. But if you see some distorted images, some distorted digital elevation model, a distorted surface, then you consider them the damaged houses. So for this extraction of this information, so you can use multiple algorithms. You have machine learning algorithms that are CNN, ANN, like convolutional neural networks. You can use artificial neural networks. You can use supervised or unsupervised classification approaches. You can use GIS softwares for these kind of applications, for this kind of purpose. You can also use probabilistic models like random forest. You can use random forest model as well. Random forest works quite good with single composite images. You need large amount of data sets, like input data sets need to be really good input data sets. But you can generate very good results using random forest, using ANN, CNN, like convolutional neural network, artificial neural network. So let me give you some example of operational guidelines. What are the guidelines that you need to follow when you are flying a drone? So first one is selection of the correct UAS platform. So you need to know which area and how you are going to fly, for what purpose you are going to fly your drone. If you are just going to fly your drone for a rescue mission, you want to know where people are located during a flood scenario, then you can use, it's not good to use the fixed wing drone, because you cannot stop the fixed wing drone in the mid-air and go to that area and then see in detail whether there is some person or not, whether you have interpreted the image wrongly or not. So you have to use a multi-rotor that gives you more flexibility, more controls over the path of the drone. So you can, in that case, you have to use a multi-rotor drone. So if you want to cover a large area, if you are to map for inundation mapping, then you have to use fixed wing drone, because it gives you, you can map a larger area using fixed wing drone. Second one is the safety. You have to practice the code, or you have to always remember the code of practice, and you always have to remember, you have to follow the guidelines issued by the Civil Aviation Authority of your country. If you are working in Nepal, then we have to work with the Civil Aviation Authority of Nepal. We have to work in collaboration with them to fly a drone. If you are working in India, then you have to work in collaboration with the Civil Aviation Authority of your country, of India. Third one is the environmental consideration. The biggest concern is the wind. Drone opposite the wind. If you are flying a drone during a hurricane, if you are flying a drone during a high wind situation, then you might lose your drone. You might injure someone. So every drone has a wind resistant limit published with that drone. So you need to consider what is the speed of your area. What is the speed of wind in your area? The fourth one is collision risk. Once the drone is in the air, the drone is always at risk. So before you select your site for flying a drone, before you set the altitude of your drone, you need to check the surrounding for hazards. The hazard includes the wires, overhead wires, high tension lines, tall trees. You need to see how, like, the height of the buildings. You need to see the people, where people have been gathered. You need to see where there is the water bodies, and you need to select the site, like takeoff and landing site, in such a way that it's an open, flat area, far away from trees and far away from water bodies, because you are working with a GPS device, GPS device. So sometimes trees and water bodies can interfere with the signals, GPS signals, and you can lose your drone, or your drone might land on a different place than the intended one. So the last one is, you have to consider, not the last one, but let's say fifth one. We have to consider the wildlife disturbance. One of the major cause of drone accident is also the birds. I have faced these kind of problems many times. When you're flying a drone, eagles, like bigger birds, they come to attack your drone, and when they attack the drone, your drone is at risk, the eagle is at risk, you might hurt the eagle as well. So the eagle mostly attacks during the horizontal approach, when the drone is doing its mission, flying for its mission. That time the birds might attack your drone, or your drone might collide with the bird. But during a vertical approach, drone is not at that much risk. But during a horizontal approach, drone is always at risk. So that much for today. I think you have got a general idea of how drone can be utilized during a disaster scenario. This is not limited just for the drone, like flooding in a scenario. This can be implemented for different scenarios. For during a landslide also, you can use the drone to detect the change. Like if you have the data from previous data before disaster and post-disaster data, then you can compare those data and identify the risk, like identify the hazard, how much impact has been occurred. You can assess the damage, you can assess the impact assessment. During an earthquake also, you can use in the same way. During a flood, mostly I have used drone in the flooding scenario. I work in flooding scenario, that's why I've given an example of flooding scenario, but the same situations can be implemented in other disaster scenarios as well. Thank you.
Thank you very much, Achyut. So, Achyut, would you like to introduce yourself, like all the organizations that you've worked with and different projects that you've been associated with? I think they're very interesting for everyone to know.
I have my name is Achyut Krishna Pandey. Let me introduce myself. My name is Achyut Krishna Pandey, and I have, for the last 4-5 years, I have been working with drone and with multiple organizations, regional, national, and international organizations. As a GIS consultant, I work as a GIS consultant for disaster risk reduction scenarios. I work with ICIMOD, International Center for Mountain Development. I work with GIZ, German GIZ. I also provide trainings through multiple organizations. I also conduct drone trainings and QGIS trainings.
All right. Thank you so much, Achyut. I think we would flow into Darpan's presentation, because I think he will also cover some parts of the questions raised by the participants. Darpan, can you take over? Achyut, you need to stop presenting your screen.
Thank you so much, Ruchi. Okay, so thank you, everyone. It's really great to be, a part of this enthusiastic crowd, and it's really great. So thank you so much, Ruchi, and everyone once again. So I'm just trying to connect my presentation, and meanwhile, I just wanted to say some things. Like in my presentation, also I had included like few aspects that are already presented in Mr. Achyut's slides. So I just quickly removed them, but I'll just go through them. If anyone has any confusions on those things, or even from this presentation, if anyone has any queries, then please feel free to ask, because we can go over those questions as well. Ruchi, can you confirm that you can see my screen?
Yes, Darpan, we can see it.
Okay. So hi everyone, once again, it's Darpan Pudasaini. So let me just confess something before starting. Like, I've been working with drones for lots of years now, so even a couple of hours is much less time for me to talk about drones and everything, but I'll try my best to be on time. Sorry, Ruchi, in advance. Okay, so the topic that I'm going to present today is UAVs in reconstruction and rebuilding. So it's almost it's like completely linked with the presentation from Mr. Achyut, and it's just a small part that comes, regarding the use case of drones. So earlier I was planning to, explain few terminologies about the few maps and utilities or data products that we can get from surveying and mapping projects, but since it's already been covered in Achyut's presentation, I just removed them quickly. So what I will do now is, I'll just walk you through two stories. Like, these are two small stories of us in two different projects that we were doing immediately after the earthquake in Nepal. So it relates to reconstruction and rebuilding efforts. And then using those two stories, we will be having key takeaways from them. Okay, so let me just go through it. So before I begin, I'd just like to give a short introduction on myself. So I've been working on the field of robotics, sensor development, IoT, and stuff like that for almost 9 or 10 years now. But from like 5 or 6 years, we have been dedicatedly working with drones. And I'm also the founder and CEO of DroNepal, which is the first Nepalese drone service company. So what we basically do is we have three models for drone services. One is drone as a service, where a client comes to us and he or she tells their requirements, and then we just take our drones, our teams, and provide them the services. Then we also have drone as a technology model, so which is more like research and development of newer systems that do not exist on the market, but that we are able to come up with. So for instance, we are doing a project with lots of stakeholders relating to medical cargo project in Nepal. And then the third model we have is drone school, where we are constantly trying to, focus on capacity building and stuff like that, that the same stuff that Ruchi has been doing. And Ruchi and us, we have been working for a long time together. So it's really a pleasure being here. So let me just start my presentation, giving a quick outline. So I'll just present two use cases. One is the use case of reconstruction of a hydropower using drones, and then another use case is the use of drones in community rebuilding. And then we'll just take the messages from them and take the key takeaways, and I'll just share with you a few of the key challenges that we have existing in the drone market today. So okay, so I'll just skip. Okay, so for the reconstruction efforts, so let me just lay a bit of background here. In a country like Nepal and lots of other third world countries, and I'm sure even in India, which has undulating terrain, like, there are lots of different variation in altitudes, variation in topographical complexity and everything. So, and specifically in case of Nepal, we have lack of updated topographical data. So we just heard from Mr. Achyut in his presentation that we have satellites as the present go-to solution, but we have that compromise between quality and cost. And also in case of Nepal, we don't have dedicated satellite for land surveying. So mostly the data that we can obtain from satellites is at least a few months or years older, depending on the area and depending on the budget of the project. So the first thing is, like, there's a problem of lack of updated topographical data. And then even if we have data on some place, it's not of enough quality. So what I mean is, like, there are different kinds of data, and so I just want to generalize it. So let's say that we need data for construction of some hydropower. Then the data that we have currently for 50 centimeters or 100 centimeters is not enough. So it's not enough for us to use that data and use it for construction purposes. It's only good enough for planning purposes. And also, so we always have that option to have a team of civil engineers and surveyors assembled and send them to the field to collect the data. But again, the problem with hard to reach terrains comes. So it's really hard and really challenging and really expensive to get data. It's not even possible to get data from all of the places, especially in context of Nepal and also in the hilly regions in India. And there's also the issue, like, so since we are developing country, lots of time and efforts are being provided by government and every stakeholder, agencies and institutions in conducting, like, from a collection of data to construction purposes. Time is really money, and we can't really waste the time because we are on limited budget, limited time, right? So these are all the problems that are existing. So I'll just go through this story. So there's this hydropower called Bhairabkunda hydropower. It's a small hydropower, really, like almost 3 megawatts or so, and it's situated in Sindhupalchok district in a location called Tatopani. So in the misfortunate earthquake that went throughout Nepal in 2015, this hydropower, Bhairabkunda, sustained severe damages. So it was already up and running and it was generating revenue already, but due to the earthquake, there were landslides in the area and there was huge boulders coming onto the powerhouse, to the diversion weir, settling basin, and everything was damaged there. And you can just see, so it's a photo of us on our way to the hydropower. So the thing is, like, after the earthquake, this hydropower had to shut down their operations because of the damages. And the thing is, like, since the earthquake was time and again coming in different multiple waves, the issue was that nobody was willing to go to the site and take all the assessment data, like just assess what the damages are and then take measurements and then make plans depending on the depending on the data from the field. So it was really impossible back then to resume the operations of the hydropower because no one was willing to go back there, because Sindhupalchok was one of the hardest hit area from the earthquake back then. So the only possible solution for it was to just wait. But the thing is, like, even for such a small hydropower, waiting for almost a year meant like losing hundreds of crores of rupees in total operations and revenue and everything. So they were actually searching for a solution. And then what happened was, they approached us, and what we were able to do was quickly assemble a small team of drone pilots and GIS engineers. And then we sent the team over to the hydropower. The benefit there was, that the drones pilots and the GIS engineers, they didn't really have to reach the sites themselves. What they did was they in turn stayed at a safe place and then they flew the drones from the safe place. So that way we could, collect all the ground realistic data from there. And then the same data was used to produce maps and visualizations. I'll just quickly go through what kinds of visualizations we had produced back then. And all these visualization and maps were quickly used by engineers in the offices, like in the headquarters of that hydropower itself. And then they were able to produce designs within a period of few months. And then, immediately after the waves were really sparse, they were able to just quickly go over to the site and reconstruct their hydropower based on the designs. So as per their view, they were mentioning us were like, if they hadn't quickly used drones in the project, it would have lost them more than a year of time. So it's really a good thing that they realized the application of drones in this purpose. So I'll just quickly go through the different types of data that are produced. So one of the data, prominent data. So if you are, I think even through this training, you will be hearing a lot about orthophoto maps. So what orthophoto maps really is, like, whenever you take drones and take pictures of an area, you only have certain frame, right? So you only have picture of small area. But when you take thousands of pictures of that area with small overlaying photos, what you can do is, you can use a lot of softwares. You have lots of options these days, and you can use the softwares to combine all those photos and form a single map, which is identical to satellite maps, but it's much more higher in quality. So these maps are called orthophoto maps. So orthophoto only means, like, ortho means it's orthogonal, or it's taken from 90 degrees straight viewpoint, and it's a photo, so it's called orthophoto map. It's also regarded as orthomosaic because it's a mosaic of lots of images. So whenever you hear orthophoto or orthomosaic, it's referring to these kinds of images that are the bird's eye images or bird's eye view of any specific area. And then there are digital maps. So using those orthophoto maps, what GIS engineers, and specifically there are people called cartographers who are the people who make maps. They are the experts in making maps. So these people are able to create high resolution digital maps that you can see over on the screen. These maps are used by engineers, and these are the maps that are usually found in printed forms as well. And then we also have like 3D maps. So it's basically like so just to give you a context, it's like, whenever we are playing a 3D game, if we are in an environment, it's like really immersive, right? We don't just see 2D image, but we see 3D image of that area. So drones are able to replicate the realistic 3D maps of the area so that people can also measure like lots of things. Like for instance, so this is a 3D map that I just downloaded from internet. So this is showing a pile of sands over a project site. So what this 3D map allows is like, engineers can directly calculate the volume of the sands from it. So it's like one dimension higher than the 2D maps. So this is only one of the features. So it had lots of other uses as well. And then we have cadastral maps. So basically cadastral maps are like those digital cadastral things. So cadastral are really land parsers or information of the land owners. So what we can do is we can get digitized cadastral information and overlay on the orthophoto maps or the digital maps that we produced. So it's easier to see or divide the land based on the ownership of the land. So I think we'll go into much deeper into all these maps maybe later in other topics. And then there's also like, simply photos and videos are also really important outputs from a drone, because just viewing the photos and videos, we can have an exact estimation of the area. We can know the ground situation, ground reality of the area. So in lots of project progress monitoring purposes, drones are used and just the pictures are enough for them. So these were all kinds of different data that we are able to provide to the hydropower survey for them to work upon. And then there's this one extra thing that I wanted to add upon. So it's called as-built analysis. So the thing is like, engineers, they build maps and designs all the time, but it's really hard to, compare after any construction work is done. It's really hard to compare whether the design specifications were met or not. So what as-built analysis allows is, you just do drone surveys and take 2D and 3D maps, and then you can overlay those previously built designs to see whether the design specifications that the engineers or experts had planned on are actually reflected on the construction work or not. So these are basically the most popular data products and utilities that are used as outputs from drone images or drone surveys. And then there's also, this is an icing on the cake. So we have seen lots of 3D printed monuments all around, right? So it's really being helpful for lots of organizations. For instance, some organization is studying glacier. So what it can do is it can use the 3D map generated from drone, and it can use 3D printing to just print smaller scale version of the 3D terrain maps. So it helps a lot in planning, and it's also a great masterpiece for showcasing and everything. So these are basically the types of data products that we can use. So after the second use case, it will all be pieced together, and we'll just take away the things that are the key to these projects, and we'll also see how drones are useful in rebuilding and reconstruction after that. So let me come to the second use case, which is drones for community rebuilding. So let's just go to the ground problem first. The thing is redundant, so we have lack of updated topographical data, and even the data that's available is not of adequate quality. And also, especially in case of post-disaster scenarios, the plannings are really crucial, right? So they need to be really quick, but we also need as much higher quality as possible so that we don't have to always go back to the field to measure something. So it's really crucial to have data quickly and then be able to act on it also quickly. And also, there's this thing like, we have been building communities for ages, but the problem with them is like the experts, engineers, architects, and GIS experts, they are the ones who make the plans in their own offices, in their headquarters. And the people who are really like layman people living in the community, they have no idea about what the layout of the community is going to be, whether it's going to be, acceptable to them or not. conforming to their cultures, conforming to the way they are living. So it's really also crucial for the community and also other stakeholders, including the donors, including NGOs that are working on the area, to be really engaged on the project of community rebuilding. So these are really hard until now, because the maps that we see are really technical maps that only the technical people can operate on and understand. So it's really hard for people to collaborate together. So these are the problems. So going into the story, there's this place called Khotan. So it's a really hilly place nearby Sagarmatha. So even I haven't been there myself physically, but I've seen lots of images and videos from there. And from what I've heard, it's really tough to go there.
Yeah.
And immediately after the 2015 earthquake, there were lots of communities that were displaced from their homes, because the whole community were, either affected by the earthquake itself, damaging the buildings, or there were lots of landslides that were induced by the earthquake that in turn swept communities, swept villages at once. So like thousands and thousands of people, actually there were hundreds of thousands of people that were out of houses, that were, forced to live in makeshift shelters back then. And the community from this Khotan, there's this place called Vijay Kharka. There's a village of around 20 houses which was severely damaged by the earthquake, and they had to quickly move those people out. But the thing is, the weather was also bad. It was constantly raining, and those people were forced to live in plastic shelters. So it was really a tough challenge for even the local government back there to choose a new place for relocating them, because minor waves were always coming and going, and also there were vast hills. So it's really time consuming and cost expensive for the government to send in surveyors and expert teams to just go and survey different hills so that they can find a suitable place. Then it's also a challenge to take high quality data of that area and use the same data to make master plans for the new community and then actually construct. So it's the process that usually takes over 1 year or 2 years, from our experience in the context of Nepal. So this was a huge challenge. So what we could do is we could really, work with the community back there, and we assembled a drone team, and then we were able to take drone surveys back there. So what we did was we took the 2D and 3D maps that we saw earlier. So it was similar to them. So we took the maps and utilities that we produced from the drone surveys, and then we were able to provide it to urban planning experts and rebuilding experts back here in our office. So we were quickly able to, have the ground reality of the area, and then we were able to select a best location that could be resilient from further disasters, because we wouldn't want to build a new community in some place nearby that would again be affected by earthquake, right? So that was the idea. And then, we were able to quickly create master plans that we shared with the community people, and the community people, they were using large flex printed maps, and they were just pinning using thumb pins and stuff like that. They were just planning, okay, so we need house in this area, we need schools in this area. So the villagers there were the real planners, our designers and engineers and experts back in our office were only implementing their vision, because the people who are going to live there, actually, they were the designers in this case. And this was the first use case in Nepal that happened like this. So with all these data products and everything, within a period of 3 months, we were able to produce and validate a master plan layout for the drone. So this is one single image that I'm showing, because it's not really possible to present the whole 3D because it's really heavy. But the idea is we were able to produce a map, and within 3 months of period, the community was actually built and people were moved in after that. So I think around 5 months of time was enough for the school and everything over there to operate or resume. So this was really quick on this. Otherwise, it would have taken like 1.5 years or more. So this is the second story, and the moral of this second story or this use case is that in no time, people got to live in a resilient community that they designed. Now let's emphasize on the word no time, because it was like 4 or 5 times lesser time that would have otherwise been required in case of traditional means. And then the people got to live in a resilient community. And we are quoting resilient because this new place was selected by experts as resilient places, which are much more resistant to further damages. And actually, the community had been participating in the design itself, so they had the ownership of the place. So these were the things from the project. So what do we learn from all these stories or the use cases? The first thing is like, data hungry process, because rebuilding and reconstruction are mostly happening immediately after any disaster or during disaster. And the government and all agencies, their attention is also divided, and it's really a tough job to manage all these things, and especially going into rebuilding and reconstruction, it's sensitive as well. So it's a data hungry process, and it's really challenging and expensive, and it's also time sensitive because we have to be more agile, because if we just took 1.5 years just to come up with a master plan and create a new village, then the villagers, whole 20 families, they would have to live in plastic shelters for 1.5 years. So we have to be really agile, and we have to come up with quickly implementable solutions. And also, so there used to be limited stakeholders engagement, right, beforehand, with less inclusion of the people, the community, the stakeholders, the different human rights people that are working on the area. So all of them couldn't participate because this process of planning and reconstruction is really technical. And also there's this case of expectations versus reality. What I mean is, like, in papers, in offices, when architects and engineers design villages or design buildings, it's really beautiful, and it's also beautiful seeing them in animations and videos. But if the designs that they have made is not based on the ground reality or on accurate data from the ground, then what happens is almost like this case of expectation versus reality that you see on the screen. So the designs might look good, the designs might be termed as longer term solutions, but in actual, the people who live in the communities or the people who live on those buildings, they'll have to go through a lot of problems, because in actual implementation of the data, or sorry, the actual implementation of the project, it's really different when it comes out. And the main problem for this is because the designs and the whole process is not based around the actual data, the accurate data, and it's not including the community itself. And also there's this redundancy of tasks. So what I mean is, like, in traditional surveying methods, for instance, you want to design a new village, or you want to rebuild a new village. So what you basically do is you send a set of surveyors, they go over there and they take the land measurements, and then we make like layout of houses, and houses are made. And for the sewerage lines, another team of surveyors goes back again, and then they take the measurements for roads and sewerage lines. And then again, a third time, a different set of surveyors go to the field to take measurements for electricity wires and telephone wires and stuff like that. And this keeps on happening. Like, it's really redundant, and it's really expensive in terms of time as well as cost. So these traditional projects or traditional means that actually did not include drone surveying were really redundant in terms of task and project management. But these all problems are solved using drones. So I don't also want to give this wrong impression that drones are the savior here. So drones are not here to replace any technology, actually. So just like we learned in our previous sessions that we have different means of surveying, like we have like lots of ground tools that are called total stations, theodolites, that people actually go on the ground to take measurements, and then we can take measurements from planes and helicopters, and then we can also use satellites. So drones are also one of the systems that add to the system. So it's not replacing everything else, but it's creating a unique place for the surveying and mapping market. So I think that's pretty much it. I hope I didn't leave any important topics. And then moving on to the challenges, while there are like dozens of challenges, I just wanted to quickly go through 3 challenges, because my assumption is that over this period of 30 days on others presentation as well, we'll come up with lots of solutions, we'll come up with lots of challenges, and you might also have assignments to find challenges in your area. That's why I didn't want to spoil the moment. So I just included 3 key things that are huge challenges, at least for the market that we are seeing right now. The first is legal, because the governments are still reluctant to completely open the way to newer ways, new innovations that are using drones for solving lots of grassroots problems. And the second one is technological, because in Nepal, in India, and in lots of countries, still, we are dominated by China or a few other countries who produce drones, who produce all the software technologies, who are actually able to provide us parts and stuff like that. So, we need more interest and more investment towards innovating and advancing this drone technology. And the third challenge is sustainability related, because we think that whenever we do a project, the problems are automatically solved. But the thing is, like, it has to be sustainable. The same process or the same project has to be replicable, and it has to be sustainable. So building the local capacity and also enabling the people in their own area to make use of the latest technology to solve their own problems, and also go into entrepreneurship is the really way forward. So these are the things that we are currently focusing on as well. So these are the 3 top challenges that I wanted to share with you. That's pretty much it. Thank you. So please feel free and come forward with any questions that you have.
Thank you very much, Darpan, for this amazing presentation. Now I would request Saksham Madan to please take over the question and answer sessions.
Yes, ma'am. Okay, I don't think we have the questions yet. So anyone who want to ask a question from Darpan sir or Achyut sir, just write it in the chat box. Okay, sir. There's a question from Anil Kumar. Does drone regulation changes from state to state? Darpan sir?
Yeah, sorry. Yes. So I think Ruchi would be more, qualified to answer for in case of India, because I have only been to few in India, like 7 or 8. But I really think, yeah. So it's mostly like, the central government, it decides on the policy itself, but there are minor variations depending on the states themselves or the local governments themselves, as per their, sensitization, or as per their knowledge on the use of drones. Because even in Nepal, so we have really small, like only 7 provinces, but we can see that the local governments which are really proactive and which have been involved with innovative technologies using GIS or drones, they have been really pushing forward drones. So the policy is the same, but they have been really forward in helping the people. So there have been minor variations on how they come ahead with the whole process of permission and everything. I'm not sure if it's the same over there.
Okay, so policy remains the same, but kind of enthusiasm from the government side differ from state to state. Okay, sir, we also have a question. Could you elaborate more on sustainability as challenge? Do you mean the context of environment impact or business viability?
Okay, so this is a really great question. So definitely when we mean a project has to be sustainable, it's not just on one thing, but it has to be sustainable on multiple terms. But mostly when I was referring to, it was mostly based on the terms of economical viability or sustainability. So let me just give you a context. So there's this project that we're doing in Pudasaini district, which is a really hilly rural area of Nepal. So we are using drones. So we have been working closely with Nepal Flying Labs, and there are a few other stakeholders. And in that project, we have been using drones for more than 1 year as medical cargoes. So we're using the drones to deliver tuberculosis samples from the primary healthcare centers in rural villages to district hospitals, which have advanced machines and more expert doctors there. But the thing is, like, we just finished, like, back in the December, we finished the first phase of the project for 1 year. But the issue that we realized was, like, if we had to scale this project all over Nepal or even beyond Nepal, the issue there is that we have to form a team of engineers that's really able to do that. For instance, we have like 3 people working on the field right now in Pudasaini. So if we were to supposedly do this project over 10 districts, then DroNepal as a company or our stakeholding committee as a So this committee, we have to make our team that's capable to handle that much. So we need human resources and everything, right? So the thing is, the challenge with sustainability is like we are not able to scale it to that limit because it's always limiting. But if we are able to, transfer the technology, transfer the knowledge that's required to run the operations to the local people. So this is the thing that we are trying to focus on the second phase that's currently going on. This COVID has really, forced us to stop the phase, but we are almost middle on the project. So what we're doing right now is we are creating a team of drone piloting experts, a team of communication experts, a team of engineering experts or maintenance experts on Bhutan itself. So the logic is that we want to enable the people there, and we also want to enable people over there to have small businesses that are around drones, so that they can carry forth the project on themselves, so that we can move to next place, train new people there, and in this way we will be able to actually scale the project. And it's only possible if the project is sustainable on its own, right? So right now we are depending on lots of investors, lots of donors for sustaining the project. But if the people over there themselves can handle the project, and if they can really make the project viable on their own terms, then we won't have to worry about donors. So it's the way to go. It's the way to have sustainable development take over. So I hope I was clear on this.
Yes, sir. Actually, we have a question. The continuation of the same, the previous question, or the community adapting the tech and sustaining the effort. Like it was in the continuation of the same, I guess.
Okay, so I didn't really get that question. I like the meaning of that question though. But could you please repeat it?
Sir, actually the same. Like Mayank asked the question earlier, and then he wrote, or the community adapting the tech and sustaining the effort. Even I cannot get this.
Okay, so I think we just got message that I just answered it. Okay, so thank you, Mike, for the question.
Okay, sir, any emergency you have handled on forest fire? It was asked by Uday Kumar.
In my case, we haven't worked with forest fires, sir.
Okay.